Okay, boys, these are the solutions to the revision questions that I gave you today. It's the 26th of August. This was this sheet here that I copied, sent to you in preparation for your 4th ATB. So these are the revision solutions. Question number 1, 5 times 0.2. Again, our decimal multiplication is no different to our regular multiplication. We can do it in an algorithm. We need to make sure we keep our decimal points in line and that we put our extra 0 up here to fill in the gaps there. 2 times 0 is 0. 2 times 5 is 10. We put our automatic 0 down because we're going up a rank. 0 times 0 is 0. 0 times 5 is 0. Add these up. Now, we count the numbers that we have after the decimal point in the question, and we go 1, 2 jumps to put our decimal point right there. And so our answer is 1.0 or simply just 1. Question 2. 1/6 plus 1/6 plus 2/6. Now, in this case, all of our denominators are equal. Now, we need denominators to be equal when we're adding or subtracting fractions. And so in this case, we don't have to do any changing. We can just go straight away to adding up the numerators. We have our plus symbols in there. So 1 plus 1 plus 2 is simply 4/6, which we can simplify that to 2/3. Okay? If we were to draw a visual or pictorial version of this, here are our whole values. Let me get a finer pen to be able to do these. We break these up into each having 6 divisions in them. Hopefully you guys can see this in the video. We have 1/6 plus 1/6 plus 2/6. So we have a total of 1, 2, 3, 4/6 or 2/3. Question 3. 1/6 divided by 2/3. Now we have to remember that when you're doing division with fractions, we don't do the division, we instead multiply by the reciprocal. Now the reciprocal, if we remember, we take this second number and we flip the numerator and the denominator to be the other way, and now our question looks like this. 1/6, that stays the same. We are multiplying by the reciprocal of 2/3, which is 3/2. And now we can simply do our multiplication. Again, multiplication with fraction, top times the top, bottom times the bottom. 1 times 3 over 6 times 2. 3 over 12, and 3 over 12 can simplify to be 1 over 4. Question 4. The square root of 1.21. Square root of 1.21. Now we need to think what numbers multiplied together are going to give 1.21. Well, let's multiply this number, 1.21, by a factor of 10 in order to make this a whole number rather than a decimal. So we need to move the decimal place 2 spots over, 1, 2, to get it over to be the square root of 121. So to move it 2 spots, we have to times it by 100. Okay, so now we're not doing the square root of a 1.21, we're doing the square root of 121. And if we remember our 11 times tables, we'll know that the square root of 121 is in fact 11. Now, since we, before doing a square root, multiplied by 100, we now need to divide by the square root of 100. Now, if we remember, 10 times 10 is 100, and so the square root of 100 is 10. So we divide this number, 11, by 10, just to get it back to its original form. Okay? This divided by 10, it's the same as moving our decimal point, which was here, back one space to the left, making our final answer 1.1. And we can check this. Now, if we multiply 1.1 by 1.1, as in if we do 1.1 squared, if we got the correct answer here, we should get the answer of 1.21. So let's check it and try it out. 1.1 times 1.1, as in a simple algorithm. 1 times 1 is 1, 1 times 1 is 1. Put a 0 down, go up because we're going up a rank. 1 times 1 is 1, 1 times 1 is 1. Adding up our values. And 2 after the decimal point, so 1, 2, decimal point goes here. So we have our final value of 1.21. So that means yes, we got the right answer when we did this value. Okay, so question 5. I need to go through these a little bit quicker, I think. 1 and 5/8 minus 2 and 1/4. When we're doing a subtraction like this with mixed fractions, mixed numerals, we want to either separate out the whole numbers and the fractions, or we can convert them to improper fractions, which is the way I'm going to do it right now. So one whole number and 5/8. So in eighths, that 1 would be 8/8. So 8/8 plus 5/8 is going to be 13/8. And 2 wholes and 1/4 is going to be 8/4 plus 1 is 9/4. Okay, so again, we don't have denominators that are equal, so let's change one of them to make sure that our denominators are equal. So 4 can be multiplied to give 8. If we multiply it by 2, what we do to the bottom, we do to the top. And so our question has now become 13/8 minus 18/8. Okay. Now, as you notice, this number is a larger number, so our answer is going to be a negative value. 13/8 minus 18/8 is going to be negative 5/8, because 13 minus 18 is negative 5, and we leave our answer over 8. Now, this can't be simplified, so that's our final answer. Question 6, 1.3 repeating, which means 1.33333 continuing on into infinity, divided by 0.5. Now, there's a trick to this question, because 1.3 repeating is an awfully difficult one to be doing division with, but we need to remember that dividing by a half is equivalent to multiplying by 2. Okay, I'll say that again. Dividing by a half is equivalent to multiplying by 2. We can think about it in a fraction. If we were to divide by a half as a fraction rather than a decimal like this, we would never do this, would we? Instead, we would multiply by the reciprocal, which is 2/1. Now, what is 2/1? It's the same as 2. So dividing by a half is equivalent to diving by 2. 1.3 repeating multiplied by 2 is going to be, well, double number 1 is going to be 2, and double 33333 is going to be 66666. And so our answer is 2.6 repeating. Okay, that's our final answer. Question 7. 1/2 minus 1/4 plus 1/10 minus 1/20. Now, because we're doing plussing and as we're doing addition and subtraction with our fractions, we need to make sure the denominators are equal. Instead of doing them stage by stage and doing these ones and then those ones and then those ones, let's change all of them to be a common number, since by looking at these I can recognize that all of these numbers can be multiplied to give 20. So let's change all our denominators to be 20 to save us a bit of time. Now, what does 2 have to be multiplied to give 20? Well, by 10, same to the top as the bottom. 4 has to be multiplied by 5, same to the top as the bottom. 10 has to be multiplied by 2, same to the top as the bottom. So we have 10/2 minus 10/20 minus 5/20 plus 2/20 minus 1 over 20. And now we simply have the denominators all equal, so we can do our addition and subtraction with our numerators. 10 minus 5 is 5, plus 2 is 7, minus 1 is 6 over 20. And of course, this can be simplified to 3 over 10. And 3 over 10 would be our final answer. Okay, question 8. Question 8 is negative 2 on 5 squared. Now, squared means multiplied by itself. So negative 2 over 5 times negative 2 over 5 is what this question is actually asking us to do. Again, with our fractions, we do top times the top and bottom times the bottom. Minus 2 times minus 2 over 5 times 5. Minus 2 times minus 2. Again, two negatives make a positive. We have positive 4, and 5 times 5 is 25. Now this cannot be simplified, and so our final answer is 4 over 25. 0.5 cubed, or 0.5 to the power of 3. To the power of 3 simply means 0.5 times 0.5 times 0.5. Now we did this in class today. A half times a half times a half. We remember that multiplying by a half is the same as dividing by 2. So 0.5 times 0.5 is simply 0.25. And so that's this part handled. This part is now this part. And that times 0.5 is halving it again. And half of 0.25 is 0.125. Okay, we can think about it as fractions as well. If it was a half times a half times a half, like this, we would simply do the same. 1 times 1 is 1. 2 times 2 is 4. It becomes a quarter. We see a 0.25 is the same as a quarter times a half again. 1 times 1 is 1. 4 times 2 is 8. And so our answer would be 1/8. Now our decimal equivalent of 1/8 is 0.125. So that is our final answer. Question 10. Now we combine our last two answers for the last two questions. Now our answer to this one was question 8. Our answer to question 8 was 4/25. So 4 over 25 minus our last one here was 0.125. But since we're using the fraction version here, we should use the fraction version of this second one, 1/8, same as our 0.125. Okay, we would need to make these have a common denominator. 8 and 25, well, this is going to be a difficult one. 8 and 8. If we ever have in doubt about what we can multiply to give, what we can do to make have these the lowest common multiple, we can simply multiply them by each other. Okay, so we can multiply 25 times 8 and times 8 on the top, and 8 times 25 and 8 times 25. Now you would be given a much simpler question than this in your test to be able to work this out, one that you could easily do and easily simplify yourself. Hopefully I've had the paper in view then. I've just noticed I bumped it a little bit. I'm just going to do this on my calculator quickly so I can check. 8 times 25 should be in fact 200, and it is. So 4 8s are 32, over 200 minus 25 over 200. 32 minus 25 is simply 7 over 200, and this can't be simplified because 7 is a prime number and it can't be divided to be smaller. Okay. Question 11. A basket contains 5 3/4 loaves of bread. So the basket here's our basket. It has 5 3/4 loaves of bread. After lunch, 3/4 of the loaves of bread have been eaten. Okay, so if we had our basket there that had, so there's our basket, and here's our quarters that it was in, 3 of those quarters have been eaten, and there's only 1 quarter remaining. So first off, we need to work out how many have been eaten, and how many are left. Well, how many have been eaten? We know that there's 3 quarters been eaten. And sorry, the question does say how many are left. So we know that if 3 quarters have been eaten, there are 1 quarter of them left. Well, what is 1 quarter of 5 3/4? We need to do a multiplication question. 5 3/4 times 1 quarter. Okay, we can do this in 2 ways. We can either do 5 times 1 quarter plus 5 times 1 quarter plus, where is my whiteout tape? There it is right there. 5 times 1 quarter plus 3/4 times 1 quarter. So first we multiply this number to the whole number and then this number to the fraction, or we can simply convert this one into a improper fraction, which would be 23 over 4. 5 times 4 is 20, plus 3 is 23, and then multiply that by 1 quarter. Either way is fine. This would give us 23 over 16, which cannot be simplified, but it cannot be made smaller values. However, we can simplify it by putting it in a mixed numeral. Now, if we take 16 out of 23, we're left with, what is that, 7? So it's going to be 1 and 7/16. Again, this can't be simplified because 7 is a prime number. So there is 1 and 7/16 loaves of bread left over from the original 5 3/4 that we had. Let's get a new piece of paper. Question 12 was, what is 2/3 of $426? 2/3 of $426. We need to remember, whenever we're trying to find a fraction of something, we multiply that fraction by the thing we're trying to find the fraction of. So 2/3 times 426 is going to tell us what 2/3 of $426 is. Now 426 as a fraction is 426 over 1, and so we can simply multiply it like this. 2 times 426 is going to be, and you might need your calculator or do some mental arithmetic to do this, but it should be 852. 3 times 1 is, of course, 3. Now, if we can simplify this, it'll make it a whole bunch easier. This 852 divided by 3 over 3 is the same as 852 divided by 3. So let's do this value and it'll tell us the answer. 3 divided into 8 goes twice with 2 remaining. Okay, hopefully you can see the little 2 there. 3 into 25 goes how many times? It goes 8 times with 1 remaining, and 3 into 12 goes 4 times. And so 2/3 of 426 we have found out is $284. And we need to make sure that we list our answer in dollars, otherwise we will not get the full marks. Question 13. What is 1/5 of 426? So what is 1/5 of 426? Again, 1/5 times 426. This as a fraction is 426 over 1. Multiplying fractions, top times the top, bottom times the bottom. 1 times 426 over 5 times 1, simply 426 over 5. Now 426 over 5 is equivalent to 426 divided by 5. So let's work this out. Can 5 go into 4? No, it cannot. Can 5 go into 42? Yes, it can. It goes 8 times with 2 remainder. Can 5 go into 26? Yes, it does. It goes 5 times with 1 remainder. And so since we have 1 remainder, we do 1 over 5. And so our 1 over 5 So our answer here is 85 1/5. Well, it's in dollars. So what's 1/5 of a dollar? 1/5 of a dollar is 20 cents. So it's $85.20. Our question 14 simply combines question 12 and question 13. Bob earns $426 a week on his way. He spends 2/3 on food and rent and 1/5 on his car. How much does he spend each week? Well, if he spends this amount, 2/3 on the rent and food and rent, and this amount on his car, if we add those together, we'll work out how much he spends each week. $284 plus $85.20. Remember, we can make sure we keep our decimal points in the correct order, and we're adding these together. This is how much Bob spends, and we give our answer in dollars each week. And so how much does he save each week? Well, if he spends this much and he saves the rest, as we're told, then we need to work out, this was part A, by the way. Part B was how much does he save? Well, he starts off with $426 and he then spends $369.20. So if we do this subtraction, it'll help us out. 0 minus 0 is 0. Make that a 5. 10 minus 2 is 8. 5 minus 9, well, that can't be done. So 15 minus 9 is 6. 1 minus 6, well, that can't be done. So 11 minus 6 is going to be 5. And 3 minus 3 is 0. So he saves a grand total of $56.80 every week. Not a lot of money. Not a lot of money to save. Okay, that's the end of our fractions and decimals questions. We're going to be moving on to the time questions. I'll leave the solutions here for tonight, and I will get a written copy of the time and the probability questions for you. Hope this helps.